In this video, I'm going to be talking about how to conduct a Manova in R using more than two groups. So we call this a K-group Manova. In the last video, I talked about how to do two groups and walked through some assumptions. In this video, I'm also going to walk through how to conduct some follow-up pairwise tests for post-hoc after the All right, so in R, and you've seen the packages that I'm going to be using, the same packages as the last one. A lot of the things that we're going to do are very similar to what I did in the last video. So to start off, it helps us to even look at a table here of what this looks like. So there are some potential issues here with these, the grouping sizes. So as you see here, some group with a 1 has 1,077 students responded with a 1 for the opinion variable, 918 with a 2, 897 3, 366 with a 4. And in this case, 1 means that they had pretty much always had opportunities to express their own opinions in math classes. Whereas number 4 means that it was never or very rarely did they have the ability to express opinions. So this last group, 366, could be something to look out for. If we look at some descriptive statistics using the describe by function psych package, we can see the first group has a mean of 499, just under 500. Skewness at kurtosis values look okay. I'm not going to go through assumption checking in this video as deeply as the last one, but just looking to see if we can expect differences. Okay, 487 kurtosis okay, and 482 for skew and we look at this for the other group, so that group was for the algebra subscores, just as the last video. If we look at the geometry scores, we see students who had lots of opportunities to express opinions, 473 on the geometry subscore. Fine, 470, 61, 456. And no problematic issues here, but it looks like maybe with geometry we might expect to see differences pop up more. We might be more likely to see a statistical difference here, even though it's important to point out that these might not be meaningfully. We can look at the plot here of what the histograms look like to help us think more about this. I go back to the plots. You can see the plot for algebra. So I've overlaid the normal distribution density curve, and it looks pretty good, although with this fourth group, there's some spiking that may indicate some issues with kurtosis. And of course, I didn't remove the NA group, so we can do that. If we look at geometry here, looks about the same with the group 4, maybe slightly more skewed on the right side skew because this grouping here that's a little higher than normal. So between that kurtosis and skew. And of course, checking assumptions would be the next thing to do. So if we look at multivariate normality, MVN function, we see that it looks like the skewness definitely is telling us that there's some issues with skewness. But when it comes to kurtosis, there's not. So apparently at the multivariate level, we see that there's some skewness issues. However, it's important to point out that with the high numbers of students in this test, it does have an impact on these tests because they are fairly sensitive to high sample size. However, we can also run the other tests that are in there. So the hence circular p-value is also very small, indicating issues with um, the Dornick-Hansen, which is not telling us that there's an issue with that it probably is normally distributed at the multivariate level. So we have one test telling us that there's no issues, and two tests telling us that there are, and histograms telling us that it looks like there's not, at the univariate level at least. So we would have to make a judgment call there using the full information. And then, of course, something that we couldn't run in the last video because of sample size, but we've dropped down a little below that from some missingness from students responding to the question about whether they had opinions in math. You can run this line, the assumptions underscore Manova, and don't forget to remove the missing data, because it won't do that for you with this test and it won't run without it. So I've just stored that into a different variable temporarily here to run this. So here I've got the two outcome measures, algebra and geometry, and this is the opinion grouping variable. And so it's showing us here that across the groups, it looks like group 3, we don't have any issues with, actually group 3 and group 4, we don't have issues with, but for groups 2 and group 1, there appears to be issues with. Part of that could be that group 4, for instance, and group 3 had smaller sample sizes, so maybe it's not impacting it as much. And then the box's test of homogeneity of covariances. Here, this is telling us, no, we don't have any problems. There's no issues with homogeneity of covariance. Otherwise, we would see a statistically result there. Going and look at the Levine's test to look at the univariate homogeneity of variances. We see no issues here. Did not meet the threshold for being too different from one another. And same thing here, no issues. So we've met this assumption of homogeneity of variances and homogeneity of covariances. We can also look at the correlation between the two. We did this in the last video. It looks like we could have something problematic here, and depending on what you look at, the cutoff for multicollinearity is 0.8 or 0.9. So we're getting close to 0.9 here. And then we can run the Manova. So run this Manova. Remember, use the Manova. The function works just like the last video, except we're using a grouping variable that is not dichotomous. So it's a factor variable. And then run the summary code. And I'm still using Wilks at this point. And we see that there is a statistically significant result indicating that somewhere there are differences based on groups. So that performance on geometry and algebra appears to somehow be related to group membership, or what kinds of opportunities students had to express opinions. And another thing we can use to help us understand how meaningful that is to look at the eta squared value. The value for this, the eta squared value is 0.002, which tells us that 0.2% of the differences we see in algebra and geometry scores can be explained by group membership. So not very much is explainable here. So even though it's statistically significant, may not be all that useful to reality. And then we can run some follow-up tests. So first, follow-up Anovas. So this will run 4 different Anovas. 2 different Anovas, one for each dependent variable. So response 1 is the first dependent variable, which is the algebra scores. So we see here there are differences across different levels of opinion on algebra. And then if we look at response 2, which is geometry, there are statistically significant differences across levels there as well. And that still leaves us wondering, well, Is it only differences between those who had um, opportunities all the time and those who never did? Or is there something more nuanced? And so that's where we can run some pairwise T-test. So this is a base function in our pairwise.T-test. And we have to run these manually, so to speak. So we have to run one for algebra and a separate one for geometry. So we can put in the algebra score, comma, opinion, and make sure to do an adjustment for Bonferroni. I prefer to use Tukey, but for this function, Tukey is not an option. So use Bonferroni here to look at those. It will make that adjustment. And we see first that it spits out this matrix. So these are the different groups, and it's comparing them to one another. So 1 compared to 2, a p-value of 1. Basically, there was no difference. They were essentially identical. And that's rounded. It can't be exact. 3 to 1, it looks like we have a statistically significant difference between those who said they had almost always had opportunities to express opinions and those who said they didn't have very many, but they had more than rarely. And then, of course, between 1 and 4, we see differences. And we also see, we don't see differences here unless we use a cutoff of 0.1. So if we're a 5 alpha value, alpha level, then we're only seeing differences between those who had a lot of opportunity and basically those who didn't have very many or who had none. For algebra. Now for geometry, it looks the same. We see a difference again between groups 1 and 4 and nothing else. So 1 and 3 and 1 and 4. Same two groups that we see differences between. So, and that's using Bonferroni. Another option would be to use Tukey's HSD. And to do this, you have to make sure that the opinion variable is factor variable. Run the Manova. If it's not a factor variable, it assumes that it is because you're telling it it's the grouping variable in the function. But here, if you make this a factor variable, then you can run this Tukey HSD, and you have to put in this code here, which is the code for running on Anova, so that it will automatically pull out the pairwise comparisons for you. So inside of the Tukey HSD AOV, then you do the same thing as with the pairwise T-test function base. Algebra score, tilde, in this case, not a comma, and then opinion. And when you run that, and Tukey is just really good at trying to get a better estimate of these, dealing with multiple comparisons. So we see here, it's going to spit out also the lower and upper bounds on the confidence interval. If we look at the p-values first, so we get 2 compared to 1. So if we're just looking for which are statistically significant, we see 1 and 3 and 1 and 4. And that's it for algebra, which is the same thing we saw with the pairwise T-test function. And of course, here it's telling you the difference between the groups. So this is the difference between 2 minus 1. That's why it's negative. 1 scored higher by about 3 points. So we're seeing a statistically significant difference here for a difference of 12 points and a difference of 17 points. So in reality, is that really that big of a difference? I would argue no, when you have a standard deviation of about 90 or 95 points. So we see the same thing. If we look at geometry, Tukey HSD, we see the same results here, differences between 1 and 3 and 1 and 4. So basically, those who had opportunities all the time scored statistically significantly higher by a small margin than students who didn't have very many or had none. Express opinion. And that is Manova with K group. Hopefully you learned something from this. Keep in contact.